Hi guys, so we're back. We're sketching parabolas still, and what I wanted to quickly talk about before I spoke about how to do this for parabolas is I just quickly want to refresh a couple of these transformation videos. This is actually something that I think gets covered, I think like grade 5, grade 6, grade 7 for you guys, and you guys look at different shapes and their transformations, but I think we might have had a slightly different name for them. So a translation, another name for a translation is a slide. So translation comes a slide. Then we've got a dilation. I don't think I have a nice little trick for this one. So this one is where it gets bigger or it gets smaller. And then the last type of transformation I have is a rotation, which is sometimes called a flip. So just to show you what this would kind of look like in real life, if I had a parabola, let's say that looked like that, I could have a vertical translation or I could have a horizontal translation. So if I've got this is my X, oh my gosh, sorry, this is my X-axis, my Y-axis, oh, I've done that the wrong way around. This is my X-axis and this is my Y-axis. There we go, third time's the charm. And if I wanted to draw a parabola that had some sort of vertical translation, it means it would be shifting up or down in this axis here. So it could be shifted upwards or it could be shifted downwards. And let's pretend they're all the same shape for a second. Let's pretend my drawing skills are on point. The other type of transformation or slide that we can have is a horizontal translation. So this is when it's moving either to the left or to the right of where it originally is. Okay, so a dilation. Let's have a look at a dilation now. So let's make this one a little bit neater, as you can see. So if we're doing a dilation, let's start off with a very basic parabola. And we know the shape of a basic parabola is going to be y is equal to x squared. That's our fundamental parabola. So if I was to dilate the parabola, so I was going to make it bigger or smaller, I do this really by making it steeper or flatter. That's not very good. Sorry, let me try that again. Oops. So if I had something like this is now a value that's a lot steeper. And if you've watched the last video, we were messing around with that coefficient in front of that value x there. So that's our coefficient a. Alternatively, we could have something that's a lot flatter. Okay, so a lot flatter. Oops. This is why I teach mathematics and not art. And when we saw something like this is when we had some sort of fraction out the front of our x squared value. So when it's bigger than 1, we can see that it's starting to make this narrower and narrower and steeper and steeper and steeper. And when it's sort of between 1 and 0, so when it's a fraction, we saw that it got flatter and flatter and flatter. All right, the last kind of transformation that we have is called a rotation or a flip. All right, so I've drawn my beautiful graph on there now. Now, if I was to flip this over, I'm going to flip it over in this direction. Okay, so that's flipped that parabola straight to the other side. So those are our 3 different kinds of transformations that we're going to see for a parabola. So let's have a look now at the equation and how we can manipulate that equation to get that variable. All right, so jumping over to Desmos, the first thing that I want to show you is I want to show you that manipulation of that coefficient, so that variable out the front. So if I was to just draw so this is my OG parabola, y is equal to x squared, and let's see what happens if I put a coefficient that's bigger than 1 out the front here. Now, we already kind of mentioned what was going to happen. So this is going to turn into something that's a lot steeper, okay, a lot steeper. And again, we mentioned this just before, if I had a value out the front or a coefficient out the front that was sort of between 0 and 1, then we can start to see that this becomes a lot flatter. And the closer I get to 0, the flatter and the flatter that this particular function is going to get. So it still does curve upwards, and it always is going to curve upwards until eventually it's going to reach that point, right? Oh, hold on, if I zoom out a little bit, you can see it a bit better. There we go. So you can see now that this is going to be a lot flatter. And I could keep going and I could do 0, 0, 0, 0, 1, but it's never going to quite reach a flat line, okay? So alternatively now, right, what would happen if I was to have a negative value out the front? So if I was to try y is equal to negative x squared. So what do we notice? Let's remove this one here, because he's quite different compared to the other ones, what do we notice is different between these two functions? I'm just going to fix this view. Okay, so we can see this a little bit better now. So all this has done is this has actually caused this value to flip. So the way that I remember with these particular functions what's going on is if I have a negative value out the front, it's going to be a sad face. Whereas if I have a positive value out the front, it's going to be a happy face. So this is our value for positive x squared, and then this is our function for negative x squared. So it's a sad face. All right, so we can sort of make some general observations or general statements now about what happens to that function when we manipulate that variable a. Okay, so here are my three rules. So if a is greater than 1, the curve is getting steeper and steeper and steeper. And we saw that, didn't we? If a is a fraction, so it's somewhere between 0 and 1, the curve gets flatter. If a is negative, so if a is less than 0, then the curve is actually going to flip over. And if we have a negative out the front, then it's going to be a sad parabola. All right, so let's do some practice equations now. Okay, so all we're going to do for this question is you're going to tell me whether the graphs are wider or narrower than the graph of y is equal to x squared. I'm not going to worry about the turning point of each one because I'll tell you right now, if something has only been manipulated by this variable a, it's going to have the exact same turning point. We saw that before when we were having a look in Desmos. The turning point is this point here. Now, keeping in mind the turning point for the other parabola is still in the same spot because it's just flipped over. It's literally exactly symmetrical. Okay, so this turning point is going to be 0, 0 for all of these functions. All right, so pause the video and then I'm going to come back and I'm going to tell you all of the answers. All right, so all I did was I just went in and I've written N for narrower or W for wider. So if this is a greater than 1, the curve is getting steeper and so therefore it's narrower. So any value or any coefficient that was bigger than 1, I've put an N next to. Similarly, if it is a fraction or if it is a decimal between 0 and 1, I've just said that it is wider. So that's our first type of transformation or our first sort of thing that we've manipulated. Okay, let's have another go now at something a little bit different. So this time what we're going to do, we're going to add a variable on the end. So I'm going to try something that looks something like this. So when our function is equal to x squared plus 1, how does this change what our function is actually doing? And remember, we want to describe it in terms of one of those three translations. So let's go back to Desmos now. And we've got our general function, so y is equal to x squared. So let's see what happens when we add just a 1 on the end of that particular function. So can we see the difference there? No, not really. If I zoom in, right, if I zoom in, all that's happened, so this was my original function, y is equal to x squared. So let's change the color of that one so that we can tell the difference between the two. And then I've got my function x squared plus 1. And they really don't look that different. And the reason for that is because all I've done is I've just moved the entire graph up 1. All right, I might pop in a bit of a higher value. There we go. So now we can actually see if I go plus 10 on the end, all I've done is I've moved that line up. Okay, so what happens then if I was to subtract 10? What do you think would happen then? Well, what actually ends up happening is it actually ends up moving down 10. But I think we could kind of predict that to happen. Let's try changing this. Let's try changing this to 20. So again, you can see the more I manipulate this, the more I subtract, the further down this line is going. So this value at the end here is called the vertical translation because it's shifting this graph up and down. So here's our general rule. So if our function of x is equal to x squared plus or minus a constant, let's actually change that to plus or minus a constant. Whoops. There we go. Then it's going to shift either up or down. So D is the vertical translation. So if D is positive, that is if D is greater than 0, the curve is going to move up. If D is less than 0, so it's negative, the curve is going to shift down. No other transformations are going to take place. All right, I'm going to pop some questions up on the screen and let's have a go. Okay, so firstly, state the vertical translation and then the coordinates of the turning point for the graphs compared to the graph of y is equal to x squared. Now, if we go back to Desmos, you can see here, this was our original turning point at 0, 0. This was the turning point of the function x squared plus 10. And you can see this function, the turning point has now shifted up 10 as well in the y-axis, because the y-axis is the vertical axis. So it makes sense that that value has changed. So the new turning point is going to be 0, 10. Can we have a guess at what this last turning point is going to be? If you guess 0, negative 60, then you're right. So all we're going to do is we're just going to say the turning points of the new curve are going to be 0 and 60, because this has shifted this curve that was at 0, 0 down 60 units. So let's go back to our question now. So state the vertical translation and the coordinates. So for this first one, y is equal to x squared plus 3. Well, we know that the vertical translation is going to be moved up 3. So let's say 3. And this is positive 3, so it's going up. And so the new turning point is going to be equal to 0, 3. So that was for question A. For question B, the vertical translation is going to be negative 1. So that's going to be down because it's a negative value. And if we have the turning point that was at 0, 0, it's now shifted down 1. So the new turning point is going to be at 0, negative 1. Okay, we've got an irrational number here, a surd. I've done a video on surds. I put it in my Algebra Basics playlist. So if you want to find out what a surd actually is, check it out. But let's have a go at this last one here, because this one's kind of a tricky looking one. So for this one here, the vertical translation, still just going to be the value that I got on the end here. It's positive root 3. So it's going to move up by root 3 units, which is about 1.7. And the turning point is going to be equal to 0, root 3. And I'm leaving this in root 3 form because it's an exact value, whereas 1.73 blah, blah, blah is not an exact value. I like easy things. This is nice and simple. All right, so we've covered vertical translation and we've covered dilation. So, and we've also actually covered the rotation or the flip. But what we haven't covered is we haven't actually gone through and had a look at the horizontal translation. So let's go through. I'm going to clear this screen and come back. All right, so the last transformation we have here is the horizontal translation. And I've got the general form for a horizontal translation here. So previously we just had something like f of x was equal to x squared. And what we've actually done for the horizontal transformation is we've actually popped in an extra value here, okay? But this is still going to be a quadratic function. Okay, so here's the question now. If we have a positive value of c, so in other words, it would be something like x, now this is a minus here, minus positive c, this is going to get a little confusing, so let's say x minus 3, then how do we think that this is going to shift, or how do we think that this is going to translate? So why don't we do this using Desmos again, just to make sure that we know what the transformation is. And again, I'm just going to leave my original function up there. So for this one, we're going to do y is equal to, let's do x, what do we say, minus 3 to the power of 2. So what do we actually notice about this horizontal transformation? Who thought it was going to the left? Because when I first started doing this when I was back in high school, I was like, oh yeah, it's a negative value. Like if we had the positive value for the horizontal, for the vertical transformation, that meant it went up. If we had the negative value for the vertical translation, that meant it went down. And usually, you know, if I add something, then the right direction is always the positive direction. So that's the direction it should go if it's plus 3. But what happens if it's negative 3? That should go to the left. That was my logic. That was my thinking. And I was actually quite surprised to learn that no, it's not actually the case. So if I have something like x take away 3, it's actually shifted it 3 units to the right. And this comes back down to this idea of the intercepts, because if I was to find the y-intercept, so in other words, when x is equal to 0, for this particular function, when x is equal to 0, this is going to be, when y is equal to 0, right, that means that this bracket in here has to be equal to 0. So then this value of x actually has to be 3 for y to be equal to 0. Okay, so it's a little bit counterintuitive. All right, so let's do another example then. So now that you kind of know the sneaky tricks, if I was to try and do something like x plus 3, which direction do we now think it's going to go in? All right, let's pop this function in. Let's see what happens. X plus 3 squared. And look, it's moved that function 3 units to the left. And again, if we were to think about intercepts, to get this value y equal to 0, this internal function here must be equal to 0. So then x must be equal to -3 when y is equal to 0. So it shifted it in the opposite direction. All right, so let's write that up now in our rules. Okay, so for this general form of the horizontal transformation, I've got x minus c. Now, if I substitute in a positive value of c, so for example, if I substituted in +3, this is going to be x minus 3. So it's a little bit weird of a way to word it, I guess. So if that value is positive, so it's x minus 3, for example, squared, then the value is shifted to the right. If c is negative, so it's less than 0, so for example, if I was to substitute in -3, negative and negative makes a positive, so it becomes x plus 3 squared, then the value is shifted to the left. Horizontal transformations, a little bit strange. I do apologize for the wording on that one. But if you can just remember x minus something is shifting right and x plus something is shifting left, then you'll be sweet. Okay, so let's pop a question up on screen. So for this question here, we've got to state the horizontal translation and the coordinates of the turning point. So if we go have a look at Desmos again, so like I said before, that turning point, the opposite sort of thing is happening to what we think. So if we have -3 in this bracket, then the turning point is going to be at +3, 0. So just like we saw at this value here. Same thing with this one. This is going to be -3, 0, and that's because if I substitute in -3, this internal function is going to be equal to 0. Okay, so that's why that's going to be our value -3 for this solution here. So a little trippy, a little weird to think about. I know, I do apologize. I haven't worded myself the best, I think. I may go back and redo this part at another stage, but just so you guys have an idea. Okay, so the first one, y is equal to x minus 1 squared. So like we said before, if it's x minus 1, then it's been shifted to the right. So shifted right by 1. And then the new turning point is going to be at 1, 0. Okay, so for B, it's going to be shifted to the right. I'm just going to write r by 2. And the new turning point is going to be 2, 0. All right, let's do a tricky one. Let's have a look at this one here. So this one is now x plus something. So that means it's been shifted to the left, and it's been shifted to the left by 1/5. And so the new turning point is going to be -1/5, 0. Okay, so it's backwards. It's the opposite to what we think. Let's do one last one, this one here. H, I do love my surds. So again, this one has been shifted to the left, and that's because it's x plus something. And it's been shifted by √3 units, which is about 1.73. And then the new turning point is going to be -√3, 0. So what happens now when we put all of these together in one single function? Well, first of all, we had our dilation of a. So f of x was equal to ax squared. So we know that a, if it was bigger than 1, it was going to make it a lot steeper. If it was a fraction or a decimal, it was going to make it a lot wider. And if it was negative, it would flip it. The next one that we looked at was f of x is equal to x squared plus d on the end. So this was our vertical translation. Actually, let's write this. So this could be our dilation, or it could be our reflection, depending on what its value is. This value d here was our vertical translation. And then the last thing that we looked at was the horizontal translation. Okay, so if we were to put all of these together, we would get a function that looks like this. So f of x is equal to a times by x minus c squared plus d. Why haven't we got a b in there? Well, we actually do. I just haven't decided to put this in this video, but we can actually put a value of b in front of that x here. But that's going to change the turning point again. So we're going to leave that one for now. We're just going to leave it like this. Oh, and I forgot to put in here our horizontal translation. Okay, so let's do a question now with all three of those put together. So I'm going to pick a tricky one because I think we've done a few simple ones. So I know that this value here is a fraction, and since this is a fraction, I know it's going to be flatter or wider, I should say, compared to the graph of x squared. So I'm always going to compare this to the graph of x squared. I also know that it's been flipped. It's a sad parabola. It's got a negative value, so it's a sad parabola. Sad face. Then it's got x plus 2. Now, when it's plus 2, it's been shifted to the left. So it's had a horizontal translation to the left by 2 units. And then it's been shifted up. So it's got a vertical translation up of 1/4 or 0.25. Okay, so how does this affect the turning point? Now, we know that when we made this flatter or wider or steeper or narrower, whatever, it didn't actually change the value. But this here shifted it to the left. So this is now going to change that turning point. Originally, the turning point of this is always going to be 0, 0. So it shifted that left too. So that's going to be -2. And then it's shifted up by 1/4. So then it's going to change that to 1/4. Okay. So hence sketch the graph. All right. Again, I think the best way to do this is in Desmos. So if I jump over to Desmos, what's the formula? -1/3 x plus 2 plus 1/4. So if I just have my x squared, and then I'm going to type in y is equal to -1/3, sorry, and then x plus 2 to the power of 2 plus 1/4. And this is going to be my turning point here, and it is indeed at -2 and 1/4. All right, so that was our video on some trickier transformations, and this is just using the equation now, so we don't have to go through that method of plotting points and like having to work that all out. I really think that this method is a lot easier, but the thing is that you need to practice it a lot more. And I think that's the kind of tricky thing about maths. As we get better at maths, we get these more condensed ways of doing things. But because we're sort of taking shortcuts as we get better at maths, we have to figure out a way to remember those shortcuts. And unfortunately, the best way to do that is with practice, because practice makes permanent. Please make sure that you are practicing the right thing. Alrighty guys, have a wonderful day. Hopefully I will see you soon, and I'll talk to you later. Bye guys.